Good morning. Here we are again. We are going to do lesson from Module 2, Lesson 3. So read this with me, even if you're whispering as you're listening along. We're going to start right here. Express metric capacity measurements in terms of a smaller unit. Model and solve addition and subtraction word problems involving metric capacity. So this lesson we're going to... I'm having problems. Oh my goodness. Looking at kilograms, liters, things like that. We are going to, let's look at this problem. This is our application problem. A liter of water weighs 1 kilogram. The Lee family took 3 liters of water with them on a hike. At the end of the hike, they had 290 grams of water left. How much water did they drink? Draw a tape diagram and solve using an algorithm or a simplifying strategy. As I am looking at this, I see a problem. I see that they took 3 liters of water, but they had 290 grams of water left, and grams and liters are not the same. However, they did tell us that 1 liter weighs 1 kilogram. So I'm going to need to convert this 3 liters of water here into kilograms. So if 1 liter weighs 1 kilogram, 3 liters weigh 3 kilograms. So this is the same as 3 kilograms. Okay, so we have that the 3 liters would be equivalent to 3 kilograms of water. At the end, they had 290 grams of water left. So we've got our tape diagram. We know how much they started with, which would be our total, correct? They started with 3 liters or 3 kilograms of water. At the end of the hike, they had 290 grams left. So what we need to figure out is, well, how much water did they drink? I'm going to put my kilograms, I think, into grams. I think that will be the easiest. And I know that 1 kilogram is equal to 3,000 grams. So if I've got 3 kilograms and I've got 3,000 grams, I've got to subtract the 290 grams that they have left in order to find out how much they actually drank. So here we are. We're going to regroup 2 to 10, and that's going to go to 9 to 10 to 9. Oh, actually, I can just go ahead and leave that at 10. So, wow, that looks incredibly sloppy, doesn't it? But we're going to try and do our best to make that work. So this will be 10. Okay, so let's look at it. 0 minus 0 is 0. 10 minus 9 is 1. 9 minus 2 is 7. And 2 minus 0 is 2. So let's just quickly make sure we're all good on that. So we should have 2,710 grams. If we did this as 3 kilograms, I would have to take my 3 kilograms and I'd need to break it apart, right? And I could turn it into 2 kilograms and 1,000 grams. Because I know that 1,000 grams is equivalent to 1 kilogram, and I know if I add 1 kilogram and 2 kilograms, I'm going to get the 3 kilograms that we started with. So I could rewrite my problem and I could say, okay, I'm going to do 2 kilograms, 1,000 grams, minus the 290 grams. So I'm going to come back down here. We're going to have to regroup. And this becomes 10. And then I have to regroup again. So this becomes 9 and this becomes 10. So 0 minus 0 is 0. 10 minus 9 is 1. 9 minus 2 is 7. And that's, I have 710 grams. I have 2 kilograms. And if you see this right here, 2 kilograms, 710 grams is equivalent to 2,710 grams. All right, we are going to look at this beaker here that's filled with some kind of red liquid. and it holds 1 liter. And how many milliliters are in the beaker? Well, but we want to find out, 1 liter is equal to 1,000 milliliters. That mil, again, means 1,000, okay? So we know that 1 liter is equal to 1,000 milliliters. If you notice here, this one is measuring down, this one is measuring up. So when we're looking at a beaker and saying how much does it have in it, we're going to look at this side. It has 900 milliliters in this particular water. So we're going to look at this. Again, we're going to look at this side in order to see how many liters are in the beaker. And if you look, it's filled right to there. So on your own, I want you to write this down on your whiteboard. Okay, 1,600 milliliters. So if I'm thinking that 1,000 milliliters equals 1 liter, I can see that I've got 1,000 right here. So I've got 1 liter, and I have 600 milliliters left over. Alrighty, we're going to add mixed units of capacity using the algorithm or a simplifying strategy. So this is what we've been doing before. Because we're adding, I like to just leave it in the form it's in. I think that's a little bit simpler. So I'm going to leave it here. I'm going to leave it just how it is because I think that's a little bit easier. So we're going to go ahead and start right here. We've got our 32 liters, 420 milliliters, and I'm going to add that 13 liters. Again, I have to keep my liters with my liters and my milliliters with my milliliters. So we're going to do that, and I'm going to add them. So milliliters, I have 5, 2 and 8 would be 10, 1 and 4, 5, and 5 is 10. So I've got 1,005 milliliters, and I have 45 liters. Now, I know that 1,005 milliliters, I know that this 1,000 milliliters is equal to 1 liter. So I'm going to change that and add it to add that 1 to my liters. So I've got 46 liters, and I'm left with 5 milliliters. Alrighty, now we get to subtract. So we're going to subtract mixed units of capacity using the algorithm or a simplifying strategy. Again, I will show you both. I want you to close your Chromebook and try to do these in the way that you feel is the most comfortable for you. So I'm going to start first. Let's just keep them as is, although I can see right away that I can't quite, because I can't say 215 minus 600. That's not going to work. So let's go with the 12 liters and turn the liters into milliliters. So that 12 liters is 12,000 milliliters, 215 milliliters. And then let's subtract our 8,600 milliliters and see what we come up with. All right, I can do 5 minus 0. I can do 1 minus 0. I cannot do 2 minus 6, so I can see I need to regroup. And I can say 12 minus 6 is 6, but I can't say 1 minus 8 either. So I'm going to say 11 minus 8 is 3. 3,615 milliliters. Let's see if that confirms, if we can stick with that doing our other problem. So if we have over here, if we decided to keep it into 12 liters, 215 milliliters, and 8 liters, 600 milliliters, you can see that we have a problem because we can't say 215 milliliters minus 600. So we're going to have to regroup. We're going to have to, remember, we'll take and do this, and we'll say, well, 12 liters could be 11 liters, 1,000 milliliters. Because we know that 1,000 milliliters is 1 milliliter, and that would still equal the 12 that we have up here, this 11 plus 1,000. So I'm going to have to rewrite this. And so I'm going to just change it right now. Instead of saying 12 liters, I'm going to say 11 liters, 1,215, because I'm going to add my 1,000 milliliters here into this spot. All right, now let's do some subtraction and see what we come up with. 5 minus 0 is 5. 1 minus 0 is 1. And 12 minus 6 is 6. 11 minus 8 is 3. 3 liters, 615 milliliters. So actually, in the end, this one right here seemed to be easier for me once I converted and changed a little bit what I was subtracting. That worked a little bit better. So you need to figure out which is going to work best for you. All right, we're going to try a word problem here. So we're going to solve a word problem involving mixed units of capacity. Sorry, I'm wobbling that around a little bit. So Jennifer is making 2,170 milliliters of her favorite drink that combines iced tea and lemonade. If she puts in 1 liter, 300 milliliters of iced tea, how much lemonade does she need? Again, so we've got to figure out, okay, if we drew our tape diagram, our total is how much she's making altogether. And it says right here she's making 2,170 milliliters. And we know that she's putting in 1 liter, 300 milliliters of iced tea. So we've got to figure out, well, okay, well, how much lemonade does she need then? Because we want it to add up to 2,170. Since we have our total up here, that tells us that we need to subtract because we're missing a portion of it down below. So we're going to take our 2,170 milliliters, and we're going to subtract 1 liter, 300 milliliters. Can we turn this 1 liter, 300 milliliters into only milliliters? Because that's what we've got up on top. If we do that, 1 liter is 1,000 milliliters plus the 300 milliliters. So we're going to have 1,300 milliliters here. So we're going to subtract 1,300 milliliters. All right, let's get started. It looks like we will need to do a little bit of regrouping. So we were okay in the ones and in the tens, but we're not okay in the hundreds. So we're going to regroup and turn that into 11. So 0 minus 0 is 0, 7 minus 0 is 7, 11 minus 3 is 8, and 1 minus 1 is 1. So 870 milliliters of lemonade is what is needed here. All right, you have done that. You're gonna head on into the problem set. Again, the teacher, our guest teacher has the answers, so you can get those from her as needed.